All right, so good morning. Today is Monday, April the 18th, 2022. And today we're going to start sine rule and cosine rule. So here's how I would start out. I would start out by saying that sine rule and cosine rule are used to solve a non-right angle triangle. So that's the first thing. Now, the tools for solving a right angle triangle are the trig ratios and Pythagoras theorem. The tools for solving a right angle triangle are Pythagoras theorem and the trig ratio. Now you're learning that the tools for solving a non-right angle triangle are sine rule and the cosine rule. Guys, solving a triangle means to find the length of an unknown side or the size of an unknown angle. So when we are solving a triangle, what we're trying to find is the length of an unknown side or the size of an unknown angle. This is something I've said to you already. At least 3 dimensions of a triangle, length of sides or size of an angle must be known before a calculation may be used to determine the size of an unknown angle or the length of an unknown side. So in other words, in order for you to use the trig ratio, the sine rule and the cosine rule, you must first know 3 things about the triangle before you can find out something new. Here's a reminder. Triangle notation. Well, the angles of a triangle, and I put in bracket, all polygons are usually labeled with a capital letter. So that's a reminder, because we would have said that already. The angles of a triangle are usually labeled with a capital letter. Now, the side in front of an angle is the side that is opposite to that angle, and it is labeled with the same letter as the angle. So all that is saying is this: the side in front of the angle C is the side common C. The side in front of the angle A is the side that is opposite to the angle A, and it is labeled common A. The side that is in front of the angle B is the side that is opposite to the angle B, and it is labeled common B. So the side that is in front of an angle is the side that is opposite to that angle, and it is labeled with the same letter, and the sides of a triangle are labeled with common letters. So the sides are labeled with common letters and the angles are labeled with capital letters. Stay with me. Now, in order for us to go further, in order for us to advance, we need to understand the idea of the inclusive and non-inclusive angle. Hear this. Now, inclusive and non-inclusive angles are not fixed. So that is important. For example, let us go. Now, the angle formed by the sides A and B is that, the angle formed by the sides A and B is the angle that is included or inclusive between the 2 sides. The other 2 angles are non-inclusive angles. So let me try and give an appreciation of what I'm saying. So I'm forming a triangle. This is the side B, and this is the side A. Now, the angle that is formed by the sides A and B is the angle that is included between A and B. So that angle here, this angle here would be called the what? Inclusive angle. It is the angle that is included between the sides A and B. Now, the other two angles of the triangle, which would be this angle and this angle here, these would be called the non-inclusive angle. So again, the sides, sorry, the angle that is formed by A and B is the angle that is included or inclusive between the sides A and B. The other two angles would be called the non-inclusive angle. All right, so here's what I was saying to you. We have the sides, the side formed by B and C. That angle between them is the angle A. A is the inclusive angle, and the other two angles would be the non-inclusive angle. Now here it is. If the side being looked at changes, the inclusive angle changes. So the angle between the sides A and C is the angle between the sides A and C is the inclusive angle between sides A and C. And the other two angles would be non-inclusive angles. All right, so in this diagram below, in the first diagram, A was the inclusive angle, and B and C were the non-inclusive angle. In the second, so if the sides I'm looking at change, the inclusive angle changes. That's all that is saying. It's nothing big. All right, guys, let's talk about sine rule and what it's used for, when do you use it, and stuff like that. Now, sine rule states that the ratio of the length of a side of a triangle to the sine of the opposite angle is a constant. So sine rule would be A over sine A is equal to B over sine B is equal to C over sine C. This is sine rule. Now, sine rule can also be written like this. Sine A over A is equal to sine B over B is equal to sine C over C. Now, in this equation, capital A, B, and C are the angles because you can only find the sine of an angle, and common A, B, and C are the sides. So in other words, the ratio of the sine of an angle, of the angle of a triangle, to the length of the opposite side is a constant. All right, now sine rule, when do we use it? The next thing is, whenever I'm using sine rule, whatever I want, I start with that. So if I want an angle, I might say the sine of the unknown angle over, let us say, the side is equal to sine So with sine rule, whatever I want, I'm going to start with. Whatever I want, I'm going to start with. If I want an angle, I'm going to say the sine of the unknown angle over the opposite side. You will see that in action in a second. If I want to find a side, I'm going to say the side I want to find over the sine of the opposite angle is equal to. So the version of sine rule I use depends on what I want to find. If I want to find an angle, I use this version of it. If I want to find the length of a side, I use this version of it. You will see You will see this in action in a minute or two. So when do we use the sine rule? There are two conditions under which we use the sine rule. First of all, we must be dealing with a non-right angle triangle. That's the first thing. The sine rule and the cosine rule are used to solve a non-right angle triangle. Now in this table, what I want to find is x. The unknown is x. So in scenario one, this is scenario one, I'm given the length of two sides. A and B are the lengths of the triangle, are two sides of known lengths. So I know the side A, I know the side B, and I know the angle what B. And I'm trying to find the angle X. So in other words, I have the length of two sides and a non-inclusive angle. So when I'm given two sides, A and B, and a non-inclusive angle B, to find the second non-inclusive angle X, that is a condition for applying the sine rule. When I'm given two sides and a non-inclusive angle. A second condition for using the sine rule is this. When I'm given two angles and one side, to find the length of a second side, that is a condition for using the sine rule. When I'm given two angles, A and B, and one side, the side B, to find the length of a second side, that is a condition for using the sine rule. So condition one, if you're given two sides of a triangle and a non-inclusive angle, to find the second non-inclusive angle, that is a condition for applying the sine rule. If you're given two angles and one side, to find the length of a second side, that is a condition for applying the sine rule. Again, the triangle must be a non-right angle triangle. So let's skip cosine rule a little and look at an example. All right, here's an example. Now, example one says, the triangle below is a non-right angle triangle, where to determine the size of angle theta. So I hope you all have your calculators ready. All right, so again, example one says, the triangle below is a non-right angle triangle, where to determine the size of angle theta. Now, ladies, gentlemen, the first thing we need to do is to look at what do we have. And based on what we have, to determine what we're going to use to solve the problem. So here, I know the length of two sides. The length of this side is 9. And the length of this side is 7.5. And the angle that I have, 50 degrees, let me ask, is that an inclusive or a non-inclusive angle? Anybody? Is the 50 degrees an inclusive or a non-inclusive angle?
Inclusive.
Anybody else? Now, the 50 degrees is a non-inclusive angle. If it was inclusive, it would be here. So The condition I have is I'm given the length of two sides and a non-inclusive angle to find a second non-inclusive angle. That is a condition for applying the sine rule. Ladies, gentlemen, this is what I said earlier. With sine rule, anything I want, that is what I start with. So the sine rule is A over sine A. Sorry, using the next version of it, is sine A over A is equal to sine B it's sine big A over little a is equal to sine big B over little b. That's sine rule. So I want to find theta, so I'm going to start by saying sine theta. The side that is in front of the angle theta is 9. So it's sine theta over 9 is equal to sine 50. And the side that is in front of 50 is 7.5. So this is over 7.5. The next thing I'm going to do, remember, I want to find the angle theta. The next thing I'm going to do is sort of like a half cross multiply. I'm going to bring the 9 up here. So I'm going to have sine theta is equal to 9 sine 50 over 7.5. That is sort of like a half cross multiply. There are other ways you could look at it, but just call it, you could say that you multiply both sides by 9, but just call it a half cross multiply. The 9 goes up to the top. What I'm going to do now, I'm going to punch 9 sine 50 divide by 7.5 in my calculator and write my answer to 3 decimal places. So this is 9 sine 50 divide by 7.5 press equal, and what I have is sine theta is equal to 0.919. I write my answer to 3 decimal places. Now, if I know the sine of an angle, to find the angle, I must use sine inverse. So theta would be equal to sine inverse 0.919. So to get the answer, I'm going to go what shift or second function. Then I'm going to press sine open bracket 0.919 close bracket. Then press equal, and answer for theta is that theta would be equal to, I have 66.8 degrees. Theta is 66.8 degrees. Ladies and gentlemen, this is sine rule. All right. All right, so let's have a look at example 2. In example 2, we're asked to find the length of the side x. All right, the first thing I would point out is that this is a non-right angle triangle. And the tools for solving the non-right angle triangle are sine rule and the cosine rule. So once that is established, the next thing you want to do is to determine which rule are you going to be using. So first of all, we have to look at what do we have. I can see clearly that I know the size of two angles.
Good morning, sir.
Good morning. That angle there is of an obtuse angle, 100 degrees. That's obtuse. Yeah. We have an acute angle, 29 degrees. So we know the size of two angles on one side. If you have two angles on one side, it is a condition for applying the sine rule. I also told you, whenever I'm using sine rule, I always start with what I want. So sine rule would be A over sine A is equal to B over sine B. So what I want is X, the length of the side, X over the angle in front of X is 29 degrees. So it's over the sine of 29 degrees. Now, the next side I have is 15 over the sine of the angle in front of 15 is 100 degrees. Remember, what I want to find is X. So again, I'm going to do my sort of like a half cross multiply. I'm going to bring this up here. So X would be equal to 15 multiplied by the sine of 29 all over the sine of 100. X would be equal to, so using our calculator, we have 15 sine 29, and this now is divided by the sine of 100. The answer I'm getting is 7.38. X is 7.38 centimeters. Ladies, gentlemen, the sine rule and the cosine rule are used to solve a non-right angle triangle. Using the sine rule or the cosine rule depends on the condition. If you have two sides and a non-inclusive angle, that is a condition for applying the sine rule. If you have two angles on one side, that is a condition for applying the sine rule. Sine rule and cosine rule only applies to a non-right angle triangle.